Hi everyone, my name is Manvi Kumbar and my student ID is 101412099. So today I will be showing you my assignment 2 for machine learning. So basically in this assignment we are going to learn about the Iris Dataset classification using the neural networking, which involves loading the data set, pre-processing it, training the deep learning models and evaluating its performance. So basically in the beginning it asked me to download the iris.csv file from the D2L, which I have already downloaded and added into my Google Colab for this email ID. So you can see in my drive I have made a folder like Colab notebooks, and it has my file which is iris.csv and my pynb file for the assignment 2, which we are using it here. So these both are added in my Colab notebooks, and then we are importing the drive from the google.colab over here. So then we are listing out all the files which are inside my notebook, where we can see the iris.csv and my assignment 2 file. Then we are finding the path of the iris.csv file, so I have named it as file underscore path, and then I have added the path of that file, which is for the iris.csv file. So if I run it, it's working properly, and then I'm reading the content of the iris.csv file and saving it into the variable named iris. So basically I'm importing the necessary library, which is pandas, and I have named it as pd, and then I'm importing I'm naming it and saving it into the variable which is iris, is equals to pd dot read underscore csv, the file path which we have mentioned in our first question A part. So it's reading the content and saving it into the variable iris, and then for checking the same thing, we are showing the first 5 rows of the data frame, which is iris.head. So if you can see over here, these 5 values are visible. And then if I show you over here, as it says, as you see, the last column contains the string. So basically you can see over here that is the updated code, so that's why it shows no value over there. You can see this is my main in GitHub, and then you can see over here it shows me that it was setosa for first 5 values over here. So it shows me the string values of the species, which is setosa, and I have to convert that setosa string into the integer 0, versicolor into the 1, and virginica into the 2. So if you can see that if I wrote this code of changing the last column of strings to the integer, you can see that all the species which were named as setosa is changed to that integer 0. Currently this shows none value because I have already updated through the help of all the questions. Then it asked me to select the first 4 columns of the data frame and name it as the data and call the data x. So basically I'm selecting the rows and the first 4 columns and labeling it as the data x and printing the first 5 values, you can see over here. Then I have to select the last column and label it and call it as y, similar to the x thing. And then I am again selecting all the rows but only the last column at this time, and then printing the first 5 labels, like the first 5 values of that, you can see. And then I have to do that, like I have to split the data x and the label y into the training and the testing segments, and calling the paths like xtrain, xtest, ytrain and ytest, and splitting the data label into the training segments while the size of the test is 20%, and use the random state 1 2 3 to make all the similars to the whole class. So I'm including the sklearn model selection to import the train test split, and then splitting the data like 80% for training and 20% for testing the data. And then I am doing xtrain, xtest, ytrain, ytest, and then splitting it and into the random state 1 2 3. Then I'm checking the first 5 rows of the xtrain, ytrain by printing these values over here. So you can see it's printing properly. And then I'm checking the length of the xtrain and xtest, and it shows me that if the numbers are like the output is 120 and the 30, that means my code is good and I'm good to continue. So if I print the values like the length of xtrain and the xtest, you can see my output is 120 and 30, that means my code is good to continue over here. Then I have to convert the ytrain and the ytest from the categorical to one hot encoded values and calling them as like a one hot train labels and one hot test labels respectively. So I am importing two categorical from the TensorFlow Keras utils, and then I am using it over here. So if I use np.array for ytrain and ytest, and then restricts the value from between 0 to 2, and I have to convert the ytrain and ytest from categorical to one hot encoded values and call them as one hot train labels and one hot test labels respectively. So basically I have to import the two categorical from TensorFlow Keras utils, and then I have to use the np.array for ytrain and ytest and restricts the values between 0 and 2, and then I am naming it as one hot train labels and one hot test labels, two categorical ytrain num classes and then ytest num classes over here, and then I'm printing the original ytrain values and then one encoded ytrain values over here. So you can see these are nan over here and these are the hot encoded ytrain values. And then if I see over here, then it shows me that define the subsequent model that contains 3 dense layers. In the first and second layers, use the 100 hidden unit neurons and the function, and then this is the question. So basically I am importing the from TensorFlow, importing the sequence and the dense over here, and then I am defining the sequence model, and then I am using the loss function for categorical cross entropy, and then compiling the model over here, and then I am using the model summary for the same. So if you can see over here, it shows me the layer output and the params for the same. It shows me the total params, which is 2953, trainable params, which is 2953, and the non-trainable params, which is 0 at this moment. Then I have to train the model using the epoch 20 and the batch 10. So I'm using the history model fit, and then I'm training the data number of epochs, which is 20, batch size, which is 10, and then I'm using the validation data. So you can see over here that this is the epoch click 20 over here. Then I have to print out the exchange shape. It should print basically 120 and 4, which is printing over here, and then I have to print the hot encoded train labels dot shape, which we have printed, which we have made on the top. It should be 120 and 3. Then I have to do plotting the accuracy and the plot loss over here. So I'm using the matplotlib SPLT to plot the accuracy, and then do the plotting the loss over here. So if you see, this is the train accuracy, which is in the blue color, and the validation accuracy for the orange in the graph, and then the validation loss has the orange color, and then the train loss is mentioned over here in the blue color. Then I have to calculate the result and evaluate the X test and Y hot test labels and reporting the accuracy for the model. And then I'm evaluating the model over here and then printing the accuracy. So if you see, the accuracy is 96.67% for my model. And then I'm printing the X test dot shape, which should be printing the X, which is 34, and then the hot encoded, which is 30 and 3. Then I'm printing the epoch again with the 50 values and the batch size 5. You can see over here, which is 50 values over here. And then I am importing the NumPy library to get the prediction for X test and converting that prediction back to the class labels and comparing the true labels with the prediction. So over here you can see which is predicted as this one, but the actual values are these. And now we repeat all the which we done in the 6th question with the following parameters. In the first and the second hidden layers, we are using the 10 hidden units and real action function. For the output layer, we need to use 3. So basically for this question, I'm using the TensorFlow, using the importing the Keras, and TensorFlow Keras importing the layers over here. So if you see over here, then I'm defining the new model, and then if I define the new model over here, that the model 2 Keras sequence layers dense activation relu input shape 4, and then like basically the first hidden layer for the 10 neurons, second hidden layers for the 10 neurons, and the output layer with the 3 neurons for the 3 classes. And then I am compiling that model and doing the summary of that new model, which we have created now. So you can see again that the layers, output shape, and the params were the same, where the total params are 193, which was 2000, which was somewhere around 2953, but now it's 193 over here. So then we are again doing the history of doing the epoch of 20, and then with the batch size of 10, and then validation data x test 1, and encoding the one hot test labels. So you can see over here for that same thing. Then we are doing testing the loss to accuracy, and if we see over here that the test accuracy is 86.67% with the loss of 0.4036, and then we are testing the accuracy of the old model with the 100 neurons, which was 96.67%, but if we test the accuracy of the new model, the 10 neurons, it's 86.67%. Then using the same settings for the question 6b part, we have to compile the same optimizer and output the accuracy. So if we do that same thing, so model 2 dot compile optimizer, if we use that, then you can see that with the epoch of 4 and the batch size of 10 with the validation data of the test x test and hot encoded test labels, you can see over here that and then we are evaluating the new model and printing out the accuracy. Then you can see that the accuracy is 0.933 with the loss of 0.34, and the test accuracy for the new model with the 10 neurons in the 4 epochs is 93.33%. Then please fit the model using the epoch of 4 and then the batch size. So again we are making the history, I'm naming it as history 3, and doing the model 2 dot fit with the epoch of 4 and then the batch size of 10 with the validation data again of x test and hot encoded test labels. You can see the epochs over here which are running properly. Then I have to calculate the result evaluating the test x test and the hot encoded test labels and report the accuracy of your model. So I'm doing the loss accuracy for the same thing, which shows me the accuracy of 0.9667 and the loss of 0.3240. So it shows me over here, so test loss is 0.3240 and the test accuracy is 0.9667. Then I have to the submission explain each line of code and the arguments we have used. Okay, I have explained each and everything properly, and then I have to show for the 10th question that how the numbers of the layers or the hidden using the impact the accuracy of the model. So basically more layers and the neurons allow the model to learn complex patterns but increase the computation time. To fewer neurons may lead to underfitting and not learning it like enough for that. Too many neurons may cause overfitting, which is memorizing the testing data. Do we always suffer from overfitting? Basically, the answer is no, because overfitting happens when the model performs well on the training data but poorly on the test data. So basically, we can reduce the overfitting by regulation, drop out layers, or early stopping. Next is how we can detect the overfitting. We can detect it by comparing the training and validation accuracy. If the training accuracy is high but the test accuracy is low, then the model is overfitting. We can also plot the loss curves, like if the validation loss increases while the training loss decreases, so overfitting is happening over there. Now, how we can reduce the overfitting? We can collect more data, use the dropout layers, randomly ignore and some neurons during the training, and apply L1 and L2 regulations. Reduce the number of neurons or the layers, and use the data argumentation techniques for the same. Next, it shows me that what happens if we change the optimizer, like over here if we see, then the 10th B, like using the different settings and the ones to choose over here, change the following ones. Basically over here is like different optimizers adjust the models weights differently, like Adam is good for most cases, so basically we use for that. And if we change number of layers, more layers make the model deeper and allow learning the complex features. Fewer layers make the model more simpler and reduce the computation but might not be capture enough the patterns. If we change the hidden units, then more hidden units allow for the better pattern recognition. and too many hidden units can lead to overfitting, and too few hidden units may also can cause underfitting for the same thing. If we change number of epochs, then more epochs allow the model to train longer but might lead to overfitting. However, the other one will prevent the overfitting but might not allow for full learning of the model. If we change the batch size, then the large batch size speed up training but may miss some of the details. However, the smaller batch size generalize the better but take longer to train for the same.